EC is a diameter, so I'm going to go over that. Oh, look, I'm given a center. Not too sure why yet. Because it's a diameter, I've got D3. Okay, but not D4. D4 seems to come from that tangent. Okay, but D1 and 2 will definitely be right angles together. Okay, EC is produced to be BD is a tangent. BD is a tangent. Okay, so let's look for tan chord. Let's see if there's tan rad. Okay, there is this radius diameter, but it's not doing anything with the tangent. It's not connecting to the tangent at the same point on the circle. So there's no 90 degrees coming from the tangent. What I do know is that D1, I'm going to make a dot. D1 is the same as E. And D4, I'm going to make a little X, will be the same as C. And that's because of tan chord. Right, I got that from the tangent. Then ED is produced to A. Yes, I can see that. AB is perpendicular to BE. Okay, they gave that. Look what I've got there. I've got D1 and 2 is 90, and B1 and B2 is 90, so I'm betting they're going to ask cyclic quad. Oh, yes, there it is. Cyclic quad. Cool. Prove it's a cyclic quad. Okay, so here I can see it immediately. What I'm going to do is I'm going to prove that the opposite angles of the cyclic quad are supplementary, or they add up to 180. I need to start from the beginning to get the D1 and D2 being 90, and that was because D3 equaled 90. So let's start with D3 and lay it all out in a logical sequence. D3 equaled 90 degrees, and that was because of angles in a semicircle. And then that made D1 and D2 equal to 90 degrees because of angles on a straight line. And that made D1 plus D2 equal to 90 degrees because of angles on a straight line. But then I'm given that B1 plus B2 equals 90 degrees, and that was given. Okay, therefore, D1 plus D2 plus B1 plus B2, they both equal 180 degrees. No reason there, that's part of my logic, okay? Therefore, A, B, C, D is a cyclic quad, and my reason is going to be converse opposite angles of a cyclic quad. What's up with converse? Well, I'm proving opposite angles of a cyclic quad, that because they're equal, we have a cyclic quad. So I can't say that I have opposite angles. I've got to say, well, I'm getting there. And converse is a way of telling that we are getting there as opposed to that's what we already have. Now we're expecting the questions to scaffold. I now have the cyclic quad ABCD, okay? So if I've got that as a cyclic quad, let's see, do we have any exterior angles of a cyclic quad that I need to deal with? Yes, but it's, no. By D, there actually isn't one. C3 will equal A1 plus A2. Okay, which I've marked out with a little X there. Okay, so because this CB line of the cyclic quad extends to give me C3, that's why this A1 plus A2 will give me the same thing, the X. Okay, then I need to look at what about my angles in the same segment. Okay, so that means I'm going to have this dot that I made by D1, that's going to be the same as A1. Okay, so I'm just going to go over all my dots again. Okay. And then I want to see about other angles in the same segment. So C2 will equal D2. My C1 will equal B2. A2 equals B1. What shall I call that? I'm going to make it a triple bar. Okay, so I've got to prove that A1 equals E, and it is according to my diagram. So the next thing is to trace my steps back to how I got each of those. I want to make a note here, which I think is worth writing down. I want you to treat the questions as new information once you've proven them. And if you realize you can't prove them, you're going to move on to the next one and assume that the previous one got proven, right? Okay, so that's what I want to do now, is to say, well, because ABCD is a cyclic quad, I went and put in all of my angles in the same segment. Okay, they're not all going to be useful, but hey, I put them all down so that I can use them. For question B, I've got to deal with proving A1 equals E. So how did I get each of those? Well, they related to D1. Okay, so D1 was equal to E because of tan chord, and then D1 was also equal to A1, and that was because of angles in the same segment, but only after I've proven A, or I've moved on from A. I couldn't have said that they were angles in the same segment and therefore I had a cyclic quad. I had to do it another way. So be careful the order in which you make assumptions. So that is angles in the same segment. Okay, therefore A1 equals E, and that's all they wanted. It wasn't anything more than that. Now there's nothing further to mark out because I've already got A1 equal to E. So yes, I am treating the questions like things that I've got in the information, but I've already got it. Okay, it was actually there before I even answered it. So there's nothing more to add, but there might have been. So I must just be aware that as I do questions, I need to go and add the information that they give me, like it's additional information for the question. For question C, I've got to prove that BDA is isosceles. And I don't have that yet. Okay, I've got to try and work my way through having two angles the same, and I don't know which ones yet. Okay, so let's work with that. So I'm just going to put here two angles in BDA. I've got to prove that they're equal. So what I'm trying to do now is relate them to some other angles and see whether there's a way I can get two of those as equal to each other. Okay, so let's look at C3. C3 is equal to D4. And D4 is actually equal to D2, right? Because of vertically opposite angles there. Do you see it? Okay. So that's actually an X over there, which means I've got D2 being a little X, but then I've got A1 and 2 being an X as well. Okay, so clearly it's going to be those two that are the same size. But I needed to see the vertically opposite. Okay, so I have D4. D4 equals C3. Remember how we got that? That was tan chord and then C3 equaled A1 plus A2. And that also came from proving the cyclic quad. So that was the exterior angle of a cyclic quad. And then also D4 equaled D2. The ones I marked out with X's because of vertically opposite. Okay, right. So, therefore I have D2 equals A1 plus A2. Therefore, I have BDA being isosceles. And my reason is that I have two equal angles. Right, what needs to be marked out from that isosceles triangle on the diagram is already marked out, so I'm ticking that off. The last thing is to prove that C2 equals C3. Okay, I actually made D2 a single bar, and then I had C2 as a single bar, because they were equal to each other because of angles in the same segment. So actually that makes C2 the little x that I had. So I've actually already had it. And if you mess up your diagrams in a way that's quite chaotic, in a final paper there should always be two diagrams, one in the question paper and one on a diagram sheet, or if it's an answer book, you should have a diagram in the answer book. So you should be given enough space to be able to make lots of mistakes and still see where you're going. Okay, so for question D, I'm just going to equate these things again. Okay, so previously I have proven things that are equal, so I'm going to say that D2 equals C2, and that is angles in the same segment. And then following from that, D2 equals D4, which equals C3. I've already proven that. You could go and rewrite your reasons if you are unsure that what you did previously works. Okay, and then because of that, I then have C3 equaling C2, which is what I had to prove.